Okay, for this video, what we're going to do is start to process some numerical data, and we're going to throw this numerical data into what we call a frequency table. Okay. Now, recall that numerical data is collected by either counting something, so counting how many instances of something happened, for example, number of cars in a car park or number of students in a class, something like that. Measuring is done well by measuring. Okay, so what we might look at is height of students in 10D versus height of students in 10C, for example. And then depending on the range of values for the data set, what we can do is set up the frequency table as either ungrouped, if we have a narrow range of values that occur, okay? And an example of something that would have a fairly narrow range of values would be something like, say, number of family members. So talking about your immediate family there, okay? So you might have 3, 4, 5, 6, 7, maybe out to 10, 11 maybe, if you're quite a large family, 12 perhaps, but it's still a fairly narrow range of values. Whereas if we have this really wide range of values, and I'm thinking here like heights of students rounded to the nearest whole number, you might get someone like at 150 centimetres through to someone who's like 176 centimetres. That's a fairly long or a fairly large range of values, or a wide range of values. So height of students rounded to nearest whole number. All right, so this first example here is ungrouped data, because what we have is a narrow range of values. And what we're doing is we're collecting data about the number of children in the families of 23 students in one homeroom, okay? So here's the list here, okay? And what we've got here is children in family, and we're going to put the number of children in the family in sequential order, and we're not allowed to skip any values. So here's what I mean. So our lowest value clearly is 1, so we're going to pop that in. Number of children in the family is 1, then it's 2, then it's 3, 4, and 5. Now, I didn't even note whether there was any 4s there, but we still need to pop in a 4, even if there isn't any, because that tally then will tell us that there's 0 4s, and that's really important to know. All right, so now let's process this list by getting a tally, okay? And the tally is usually done when we haven't got the data already. We'd be doing this live, so we'd set this up and you would move around the class of 23 students and take the tally, and then later on process the frequency. But we've actually already collected the data, so we're going to cheat a little bit and just put our tally in, even though it would be a redundant move. Right, here we go. We got 1, 2, 3, 4 ones. So we've got 4 of them. Now we're going to go to 2s. 1, 2, 3, 4, 5, 6. 6 of them, I think. 3s, we've got 1, 3, 4, 5, 6, 7. 7 of them. 4s, 1, 2, 3, 4. And it looks to be 2 5s left over. All right, let's just do the error checkings. That's 4, that's 6, that's 7, that's 4, that's 2. Add these up and it should equal the number in the question, 17, 21, 23. It does indeed. All right, now what we're going to do is look at the percentage frequency, and that's the, in terms of this, we would say of the 23 people in one homeroom, what percentage of families have one child, okay? So to do that, what we would do is it's 4 relative to the class of 23 students. And we're going to convert that to a percentage by multiplying by 100 and probably round that to a specified number of decimal places, even though this question doesn't say to do it. So we're going to go to, say, 1 decimal place. Now, again, the question should tell you how to round it. Okay, 6 is going to be 26.1. 7 is going to be 30.4. That one there is going to be 8.7. And that one is 4, which is the same as this one, which should be 17.4. And when I add these together, in theory, it should equal 100. It may not because of rounding, okay? So if it gets to 99.9 or 100.1 or 01 or something like, or 100.1, then that's okay if you've rounded to the specified number of decimal places, okay? So don't panic if it doesn't actually add to 100, but do panic if like you add the percentages together and you get 80. Okay, that's of concern, obviously. All right, so that's our first frequency table here. Let's go a second one here. And what we're going to do with this one here is group the data. Now, why do I know that? Well, I can see here that I'm collecting information about university participation rates, and it might be, I don't know, in Melbourne suburbs or something like that. So this might be a suburb that has a uni participation rate of 26%. 3%, 12%, etc., etc. Okay, so don't know whether it's country based or what, but anyway, it doesn't really matter. We're just going to process this list. Okay, so we can see here that the lowest value is 1, the highest value looks to be 55, and that's just way too wide a range of values to start writing it in individually, like 1, 2, 3, 4, 5, 6, 7. You can see here it's going to go all the way up to 55, and it's just going to be ridiculously long. So what we're going to do is think about how we're going to group it. Now, notice that the frequency table has been set up with 4, 5, 6 gaps, okay? So basically it looks like we're going to separate them into roughly groups of 10, okay? So what I'm going to do is put the participation rates to be 1 through to less than 10, okay? So that's my first grouping that I'm going to do there. 1 up to, but not including 10, okay? Then I'm going to go 10 up to, but not including 20, 20 up to, but not including 30, 30 up to but not including 40, 40 up to but not including 50, and 50 up to but not including 60. Okay, now some students set the last group to be 50 to 55 or something like that, but you've got to keep the group size absolutely consistent. Once you set the spacing for these groups, it's got to be exactly the same throughout. All right, so the next thing we're going to do is count how many fit the 1 through to less than 10. And also we're just going to count up the number of pieces of data so that we can know what the frequency should add to. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Just so happens it's also 23. All right, so let's get 1 through to 10. So that one, so that 1, 2, 3, 4, 5, 6, 7. All right, so I think it's 7. Now let's get 10 through to 20. 1. Now see this one here, 20, that's on the fence. This says 10 through to less than 20. 20 doesn't belong to this group. This is less than 20. Okay, so 20 belongs in this group here. So we're going to ignore 20. So we're still on 1, 2, 3, 4. Okay, now we're going to get 20 through 30, not including 30 itself. 1, 2, 3, 4, 5, 6, 7. Just ignore that line there. All right, 30 through 40. 1, 2, 3. 40 through 50. Nothing. 50 through 60. 1. Okay, so these should add to 23. I feel like I've missed one. I wasn't too sure whether I've processed that one yet or not. So let's find out. So I've got 7, 4, 7, 3, and 1. And we're going to pop a 0 in there just to emphasize that. So what we've got here is 11, 18, let's go again, 11, 18, 21, 22. I have missed one, and it's probably this 22 here. So I'm going to add that to this list here, change that to an 8, and that's going to give me the 23 that I require. All right, so now what we're going to do is look at the percentage frequency. So to do that, recall I'm going to do this happens 7 times relative to the 23 that we looked at, multiplied by 100. So I think we did one that in the other calculation. But anyway, that's 30.4. That one, we have got that one already. That's 17.4. This is 8, which should be double 17.4, so it should be 34.8, but I don't trust myself on that, so I'm just going to do it 34.8, yep. 3, 13.0, that's obviously 0, and this one is going to be 4.3. All right, when I add these together, I'm going to get, let's see, 30, 17.4 plus 34.8 plus 13 plus 4.3. And we did get, in this case, 99.9%, but that is okay, and it's because of rounding, okay? So that's perfectly acceptable. All right, so now what I want you to do is go on to worksheet 1, organising data, and do the second page of that, coupled with the set 9A questions from the topic outline.